Good evening, everybody. Welcome to the December Astronomy on Tap Groningen, to the December edition of Astronomy on Tap Groningen. It's a pity that we can't be all together in person, and I cannot really see all of you, but I'm sure that there are a lot of people joining from different parts of the world, and it's really great because also today we have an incredible guest. And first, I would like to explain a little bit how the event will go tonight. We will start with a small chat about the recent astronomy news. Afterwards, we will move to the main talk with our invited guest tonight, after which we will have a question and answer session, and then we'll have a really fun pub quiz. In order to tell you a little bit about the astronomy news, I would like to invite my colleague, Valentina. Hello, Valentina.
Sorry, hi. I was hearing many times your voice, so I wasn't sure when to go in.
Hello, Valentina.
Sorry, hi. I was hearing yeah, I can also hear my voice. Sorry. So I wasn't sure when to go in.
Hello, Valentina.
Sorry, hi. I was hearing yeah, I can also hear my voice. Sorry. So I wasn't sure when to go in.
Okay, we had a little bit of echo, but I think now we can.
I think it should all be good now.
Okay.
Yes, is that okay? Sorry, but I didn't know when to go in because I could.
But I think now we can.
I think it should all be good now.
Okay. Yes, is that okay? Sorry, but I didn't want to go in because I could.
Now we can.
Yes, is that okay? Sorry, but I.
Okay, now really good.
Okay, thank you, Jake, sorry.
Okay.
Yeah.
Okay, now really good.
Okay, thank you, Jake, sorry. Okay, let's start with the very first news item that we would like to discuss. It's the upcoming launch of the James Webb Space Telescope. James Webb Space Telescope is jointly developed by NASA, the European Space Agency, and the Canadian Space Agency. James Webb Space Telescope is jointly developed by NASA. JWST is extremely and the Canadian Space Agency. I'm really sorry, but I hear a lot of echo. Yeah, so it's not only me, right? It's just a lot of echo in general.
Mm-hmm. Yeah.
Well, hopefully that's.
Yeah, now it's really, really good.
Okay.
Yeah, can you hear me?
You
Sorry,
found all
I
the
was
problems.
hearing all this echo and I couldn't hear you well. I'm so
Now we're all good. Sorry about that technical disaster, but now we're all good.
Okay, no worries. So I was saying that JWST will provide improved infrared resolution and sensitivity over Hubble, and it's very, very exciting times. And recently we had a little bit of scary news because we heard that the launch of JWST will be postponed, but luckily it was postponed just by a couple of days. So now the launch is set for December 22. And I think that all astronomers across the planet are just counting down the days until the launch of the telescope, and it will be a great present, Christmas present also for many astronomers across the globe. Valentina, are you looking forward also to the launch of JWST?
Yeah, I guess like everybody else, I am. I don't know, how many times has it been pushed back, this launch?
Yeah, I think many times. But I think it's also such a complicated telescope and so advanced, and yeah, that's why it's not no wonder that the launch has been postponed many times, because you better make sure and do all the tests, perform all the tests to make sure that everything works and that we're ready for the many great upcoming discoveries.
Yeah, I guess that's true. And but that also has like increased the impatience of people for getting this new data and seeing this amazing project finally being launched. So hopefully everything goes well and we can enjoy new results very soon.
Yeah, I hope so too. I think we can go to the next news item that we had on our list. And this one is related to the launch of DART mission that happened on 24th of November. And the DART mission will be the first ever space mission to demonstrate asteroid deflection by kinetic impactor. It's also extremely interesting mission because it will fly to the binary asteroid system that is called Didymos, that consists of two asteroids. The larger one is called Didymos and the smaller one is called Dimorphos. And what will happen is that the DART spacecraft itself will impact Dimorphos nearly head-on. And because of this, the orbital period of the asteroid, of the smaller asteroid, will decrease a little bit, and it will be observed from the Earth. So it's extremely interesting and also important technique to be tested, because we know that there are a lot of asteroids in the solar system, and some certain numbers of asteroids are considered as potentially hazardous. And therefore, it's very important to make sure that we have the necessary technique to deflect an asteroid danger if it will be it will be happening in the future. So I think it's extremely interesting. And I also have a tricky question for Valentina. Valentina, did you watch a movie, Armageddon?
Yes, of course I watch Armageddon.
Do you remember how they tried to deflect an asteroid in the movie?
Yes, and I won't tell that. I don't know if everybody has watched the movie, so maybe I shouldn't say how it finished.
Yeah, but well, okay, now it's the question, either we spoil the movie or we discuss if the movie is scientifically correct or not. But if I remember correctly, I will spoiler the movie. So, well, if somebody didn't watch, I'm really sorry about that. Don't hate me. But yeah, the idea is that they try to just explode asteroid. So basically, they sent a team of miners to drill an asteroid and place some explosives inside, and then in this way to deflect an asteroid. So the tricky question, well, not tricky, but just question from me to Valentina. Do you think that the way how they deflected an asteroid in Armageddon, if it was a good idea? Well, if we think realistically and scientifically about it.
Okay, but I don't think so, because somebody had to stay back to do it. I don't think they thought about it very well in the movie, and it doesn't seem to be what they want to do with this mission in particular. So I would say no.
Yeah. So also interesting thing is, if you have an asteroid that is coming close to the Earth and it's potentially dangerous and hazardous because it's on the crash course with the planet, imagine that then you try to explode this asteroid from the inside. So then instead of one planetary body that is on the crash course to Earth, you will end up with thousands of, well, smaller pieces, but still with 1,000 of other pieces that will have completely unpredictable trajectories. So exploding asteroid from inside, it's a very, very not a good idea. So, but just giving a small push to the asteroid to change its orbit slightly, that's a very good idea. And we just need to wait now 1 year until when the DART spacecraft will impact small asteroid Dimorphos, and we will see how efficient this technique is.
Okay, great. Yeah. Well, next item on the news, it's the last flyby of the solar orbiter, like the last pass of the solar orbiter close to the Earth. And this solar orbiter is a sun-observing satellite that is studying the sun like we've never done before. It was developed by the European Space Agency, and its intentions is to do detailed measurements of the inner heliosphere. And well, look at the sun very, very, very close, look at the polar areas of the sun that we haven't studied really at all. And this mission was launched in the 10th of February in 2020, and it's going to last 7 years. And last 27th of November, it did the last flyby. And this last flyby was actually a bit risky because it approached the Earth almost at the same distance as the International Space Station, meaning that it had to pass through two different orbital regions that were populated by a lot of space debris. So it was a very, very risky flyby, but after this flyby, it will like take the kick from the Earth, from the gravity of the Earth, and will go directly to the sun now to look at it as close as it can. I don't know what you think about this news, Katia. Do you think it's gonna do like interesting science? The solar orbiter?
So. Yeah, I'm pretty sure that it will be very interesting. And also, I think it's, so when I was reading more about solar orbiter, I also, I would try to read a little bit about I don't know if it's correct to say predecessor, but I assume so, about SOHO, another solar orbiter observatory. And I found an information that, for example, SOHO mission was planned only for 2 years, and now it's operational for more than 20 or even 25 years. And I thought that this is just so incredible that we have so many space missions that when we plan them and we launch them, we're very careful about saying for how long they will be operational. And we say, yeah, that will be a couple of years. And then these missions, yeah, they just work brilliantly for so many more years. And then we always find, or at least we try to find ways how to extend these missions. So when I read that, yeah, Solar Orbiter is also planned to be operational only for a couple of years, I think it's just also very interesting about all the new data that we'll get about the sun from the observatory. So I would just say stay tuned, and we'll learn more about our favorite star. That's really exciting.
Yes, I agree.
Okay, let's move to the next news item. And this one is about the new exoplanet discovered. And I guess many people will say, well, we have around 4,000 exoplanets discovered. Why this one in particular is interesting to talk about? Well, this exoplanet belongs to the type of exoplanets that are called ultra-short period planets. And this type of planets, they have very, very, short orbits. Usually it's less than 24 hours. And this planet in particular orbits its star in just 8 hours. And what is interesting is that we don't really know still how these planets form. So we think that probably they form at further distances and then they migrate closer to their host stars. And in particular, this planet is very interesting because, well, first of all, it's one of the lightest planets that was found so far. And additionally, of course, the question of habitability for this planet is not existing because it's just orbits too much close to its host star. So there is no chance for any kind of atmosphere to survive, or there is no chance for any life, at least for life as we know it, based on Earth, for any type of life also to survive on that exoplanet. But what we know is that this exoplanet orbits around the red dwarf, or we also M dwarf star. And this type of stars typically hosts multiple planets. And so the idea is that by trying to look for more planetary objects in this system, we can learn more about how exactly this type of exoplanets form. So where they form, and then how do they migrate to this to distances that are so close to their host stars. So this is also very exciting because with every new exoplanet, it adds up to the already large statistics that we have, but also it gives us more information about the great variety of exoplanets and different formation scenarios that we know. Valentina, do you have a favorite exoplanet?
Well, exoplanets are not my area of expertise, so not really. Oh, there was this exoplanet that I think it was like an ocean world that I thought it was really cool. I think, or maybe I'm mixing it up with a movie, but I'm pretty sure that it was an ocean world exoplanet, or they thought it was like filled with water. Or something like that, or maybe not water, but something like liquid.
Yeah, well, I don't think we can directly, well, in our solar system, we can study planets in much greater detail than exoplanets, but at least from the indirect measurements, we can find out what should be the composition of certain planets. So yeah, there should be also potentially ocean worlds. So that's also very cool. And actually looking forward to the JWST observations, because James Webb Space Telescope will provide us really a lot of new information about different branches of astronomy, of course, but about exoplanets as well.
Maybe looking at the ocean world that are out there with the James Webb. Well, next in the news, last but not least, this is a discovery that was done actually here in Groningen, but here for us, maybe not for the people that are watching right now, but here for us, very close research being done very close to us, and done by Pavel Mancera and Filippo Fraternali, a group that works here in the University of Groningen. They discovered a galaxy called, let me look the name, AGC 114905, which supposedly has no dark matter. So maybe some of you that are listening don't know, but until now we believed that the galaxies need dark matter to keep themselves together, to be able to function as a galaxy and rotate, like all the matter to rotate around the center of the galaxy. And they have discovered in this galaxy in particular that they don't need dark matter to explain the motion of the gas in the galaxy, which is very, very interesting because, well, it's not the first time that it's observed really, but it's a really, really new result and unexpected result, as like the scientists have said. They were like thinking maybe there's something wrong with our observations, but they did like literally a lot of hours of observation to like understand what was happening with this galaxy, and they discovered that there is actually no dark matter needed for this galaxy to exist, which is, I think, very interesting.
Yeah, I was wondering what would be the well, the explanation, the possible explanation why why in this particular galaxy there is no dark matter.
Well, they don't know yet, but I mean, of course, they will continue to study other galaxies that behave like this one. But they think that maybe a nearby large galaxy has stripped away the dark matter from this smaller galaxy. But the problem is that there doesn't seem to be any culprit for this crime of taking away the dark matter from this galaxy. They also look at other explanations besides dark matter that would explain how the galaxy actually moves, but they need to be still look for the right answer. It's a mystery, like a lot of things in science.
And that's why it's beautiful, right?
Yes, I agree.
Okay, well, that were all the news for today. Thank you very much, Valentina, for joining. And
Thank
now,
you for having me. I'm trying to stop sharing because yes, thank you for having me. And yeah, I'll see everybody later in the Zoom pub if you want to join. We'll be there. If you have any questions, join us.
Thank you, Valentina. And now I would like to present our today's guest, and it's really great honor, and I'm also quite worried, so my cheeks are very red. Our today's guest is Professor Dr. Dame Jocelyn Bell Burnell, who was responsible for the discovery of pulsars while she was a radio astronomy graduate student in Cambridge. And subsequently, she worked in gamma ray astronomy, X-ray astronomy, infrared and millimeter wavelengths astronomy. She has been president of the UK's Royal Astronomical Society. In 2008, she became the first female president of the Institute of Physics for the UK and Ireland. In 2013, she became the first female president of the Royal Society of Edinburgh. She received many honors, and for example, in 2018, she received a $3 million Breakthrough Prize for her scientific discoveries, but also for her lifetime of inspiring scientific leadership. And all the money that that Professor Bell Burnell received due to the Breakthrough Prize, she donated to charity in the UK, whose mission is to support physics graduate students from underrepresented groups. And I would say that Professor Bell Burnell's story has been both an inspiration and motivation for many female scientists across the globe. And I'm very honored that you agreed to be our tonight's guest. Welcome. Thank you very much. It's really great to have you here.
Thank you very much. Am I heard okay?
Yeah.
Okay. Start the slideshow. Okay. I'm not sure how I'm going to. Sorry, I'm not able to get this slideshow up unless it is already up.
No, not yet.
If you start the show in PowerPoint, then you can use Alt-Tab on the keyboard to get back to the Zoom. So then you can press the share screen and share the slideshow.
The Alt-Tab, right? Was it Alt something else or just Alt?
No, Alt-Tab.
Alt.
And that should switch you back into Zoom.
Nope. It's not. Nothing.
Can you get into PowerPoint and is the show started?
Yeah, I'm in full. Yeah, I'm in slideshow at the moment. Should I come out of that?
Yeah, I'd come out of that, then share the screen and then go back into it.
Slideshow. Bar. Not doing what I expected to do. Sorry, I'm thoroughly stuck.
Can you get back into Zoom and then you can press the share screen? And then from there we should see stuff.
Not getting into Zoom. Aha, Zoom. Right, let's try that. Join a meeting. Gosh.
We're in a meeting. So that's
In a
not it.
meeting, yes.
Now not. I think she'll come back.
Okay, so we have a little bit of technical troubles, and I think this is all the fault of the recent update of the Windows operational system, right?
Yes, for sure.
Yeah. So I'm very sorry about that, but yeah, blame it all on Windows. I hope we will not get sued for saying this.
Tech crew sitting behind me has endorsed the blame to be passed to Windows. They fortunately don't own YouTube, so the stream will be still there.
That's really good. Okay.
I hope she'll try to rejoin the meeting.
I would like to invite Valentina back. So while we're waiting for Professor Bell Burnell to rejoin, we will discuss a little bit more about astronomy news and astronomy in general.
There's Valentina.
Yeah, Valentina is joining. Yeah, I'm very sorry again. Our apologies for the technical troubles. Hello, Valentina.
Hi, I'm
Hello.
back.
Yes.
So we can keep talking about the news.
Yeah. So I don't know, what was the most exciting item of the news of tonight for you, professionally or also personally?
Professionally, well, I don't know. Professionally, I guess James Webb for sure, but I think that's true for everybody. No?
Yeah.
I think in the scientific community there is like a lot of expectation about when this mission is going to get launched and when are we going to start seeing results and what's going to happen with it. And I mean, while I've been reading about it, it sounds amazing. Like it's going to be amazing when it happens. So, oh, she's back. I see her.
Yes.
Yep, sorry,
Great.
I'm having huge trouble, as you can see. It's
No worries. We
It's
told
okay.
everybody that this is a.
Yeah, we've been blaming Microsoft for
Yeah,
everything
yeah.
in the meantime.
It's okay.
So I've got a PowerPoint ready. It's not actually in slideshow yet, which I think is the right way around.
Yeah.
Yep.
So do the share screen and then do the start slideshow. Should be perfect.
Share screen is under the photos.
Yeah.
Share screen. Screen.
Yeah.
Yep.
Oh,
Okay.
perfect.
And now I'll go into slideshow and we'll see what happens. Where the heck is slideshow? There's slideshow from the beginning. Okay. That look all right?
Yeah.
Excellent. Apologies for all that.
No worries.
So I wanted to say a little bit about transient astronomy, stars or things that flare up and die, particularly at radio wavelengths, because that's where a lot of the interest has been just recently. although there's activity at many wavelengths, because this time domain astronomy is one that's developing very, very fast, and will develop even faster when the Ruben telescope gets going. So I'm going to be talking mainly about the radio part of the spectrum. There is activity in other parts, undoubtedly, but in 20 minutes, I can't cover the whole spectrum. So I'm going to focus on the radio astronomy bit of the spectrum. And this is related to the pulsar work that I was involved in 50 years ago. It's a development from this, a development noticed and driven by pulsar astronomers. So pulsar astronomers are watching how the signal from a star up in the sky comes and goes, how the radio signal comes and goes. And one of the things that they learned about was dispersion. Now, dispersion in radio astronomy is quite sophisticated, so I thought I'd start with dispersion in optics and optical astronomy. And you perhaps know that if you shine a beam of light through a prism or through a raindrop, you get this lovely spread of colors. The full rainbow, the spectrum of light. Something similar happens with radio waves. You get the spectrum spread out. And I'm going to illustrate it with this diagram, which is nothing to do with astronomy, but is a terrestrial effect. Early radio amateurs heard a number of curious clicks and whistles and things on their headsets when they were listening to, trying to pick up Morse code from a colleague or whatever. And this is a plot of frequency against time, and it's one of the samples of what you might hear. And there's two events that are more or less vertical. These are very local things, and they're broadband, moderately broadband. This one doesn't quite reach the top, and this other one doesn't fully reach the bottom, but they're broadband. But in amongst all these broadband things, they sometimes heard something else. So in amongst all the hissle and noise, you'll have heard a descending whistle, a note that started high and then came down lower and lower. I'll play it again, I hope. It's going below the... Oh, I can't pick up the icon. It's hidden behind the what's it band? Anyway, pulsar astronomers regularly listen for this kind of whistling descending note, and they regularly make this kind of plot, because these kinds of signals, which are local, would also give a pulse. But because these right and left signals are local, they're not dispersed. All the frequencies arrive at the same time. It's only when a radio wave travels a distance that it gets spread out like this. And the further the distance it travels, the more spread out it gets. So people studying pulsars always make this kind of plot. It's called a waterfall plot, and they look for this descending note. So here's a couple of examples. Here's, for instance, on the right, top right, is a lovely clear pulse, and below its waterfall plot. Starts at high frequency. It follows a slightly curving track as it goes to lower frequencies. Left-hand plot shows a noisier example, but there is a pulse there, and you can see its lovely curvature in its dispersion plot. So this is a sure way of ascertaining that you've picked up a pulse from somewhere distant. So pulsar astronomers on one occasion saw a lovely clean pulse and a lovely clean dispersion curve as it falls lower and lower and lower. The snag is this curve was going down very, 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 very slowly, which means that there were an awful lot of electrons, which are the things that do the damage, there were an awful lot of electrons between the source and us. In fact, so many electrons that they couldn't all be provided by the galaxy. This had to be from beyond the galaxy. And up till then, no pulse had been detected from beyond the galaxy. So it's extragalactic because it's highly dispersed. It was also from a, sorry, I'm having a lot of trouble tonight. It was also from a spot where there had been no previous pulses of any sort, and there was no optical object there or no X-ray there. And when they worked out the total number of electrons, yep, they really agreed it had to be extragalactic. For a long time, it remained the only pulse like this and therefore considerable puzzle. But the signal to noise is very, very strong. And then they began to find others. So here are a number of them. They're all moderately clear, standing up above the noise. They've become known as fast radio bursts, FRBs, and then they give the date on which they were detected. So this is the 11th of February, 2020, and so on. And they're short, they're bright. They put out more energy than the sun does in a week. We've now seen over 3,000 of these. A handful of them repeat, but mostly they don't. And the amount of dispersion, that curvature, means they're extragalactic. They're typically at redshifts of 0.5 to 1. And there was a big question, and to some extent there still is a big question, what are they? What's causing this? What's going on? Radio telescopes all around the world were looking for these. The Parkes radio telescope picked up some of these and also picked up something else that didn't really make sense. Oh, sorry, that slide shouldn't be there. This is the Parkes radio telescope, and it was picking up some other bursts. Now, Parkes is in Australia. It's in a very remote part of Australia. There are lots of kangaroos, making driving at night difficult, but otherwise there isn't a lot of life. And Parkes has a small building as a residence for visiting astronomers, which is about half a mile away, or a kilometer or two. And they couldn't make sense of these other kind of pulses they were getting until a graduate student, bless them, made a plot of how these pulses fell with local time, with time of day, not astronomical time. And you can see there's a peak around about the middle of the day. What do we all do in the middle of the day? We have lunch. And some of us use a microwave oven to heat our lunch. There's a microwave oven in the residence, a kilometer away. They wouldn't have a everything's behaving rather badly tonight. I'm in a bad way. They wouldn't have a microwave on site, but they had one in the residence. And they had actually tested the microwave. They knew it did not leak microwaves. But then they had an idea. And mobile phones are normally banned on site, but one astronomer in the control tower with a mobile phone, another astronomer in the residence with a mobile phone, and a long stick. And they'd set the microwave going, and then the guy in the residence with the long stick would open the microwave without turning it off. And the guy in the control room with the telescope would say, yep, there's a burst. You better do it again. So they shut the microwave, set it going, opened it with a broom. Yep, there's a burst. It turns out that if you open a microwave oven without stopping it, it takes a fraction of a second to stop. So you get a chest full of microwaves in that fraction of a second. Probably not too dangerous, but probably not healthy either. Microwave ovens do not switch off the moment you open the door. they keep going for another microsecond or so. So I recommend, certainly I now always turn my microwave oven off with the button before I open the door. So having solved what these rather peculiar Australian special bursts were, that they were their local microwave, we could then get on with solving a bit more of the science. So many bursts have been seen, by now about 3,000. And they all have this very high dispersion. That dispersion curve drops very, very slowly, which means the sources are way beyond our galaxy at redshifts of about 0.5 or 1. Few seem to repeat, yep, and we're still trying to work out what they are. In Canada, the CHIME telescope, this is it here, distance, this is it rather closer up. It's 4 cylindrical troughs with the antennae, a linear antennae along like this. And it has been picking up bursts very successfully, and it's recently published a catalogue of over 1,000 of these fast radio bursts. It cannot position them very well, but the Australian telescopes have been rather good at positioning fast radio bursts, and this slide shows some of them. So for instance, in the bottom left, it's there, a bit off from the center. In this one, it's vaguely around the center. I think this one's also vaguely around the center. And you can see rather better the error circle in that one. So these things seem to be coming from something in galaxies. There are 24 repeaters so far seen, 612 total, I believe, and about 20 galaxies like this have been identified. But we still don't really know what it is. It's something in a galaxy. Big deal. That doesn't help us a lot. One chime. What's happening? I'm going backwards. Right. Okay. One of the things that interests cosmologists are what are called the missing baryons. Studies of the cosmic microwave background with things like the Planck satellite showed us that particles they call baryons, roughly speaking atoms, make up about almost 5% of the total mass energy of the universe. The snag is we're only getting about 2.5% of that 4.8% in stars and galaxies. So only about half of this stuff we know is in stars and galaxies. And the other half of, must be fairly normal matter, is still missing. Now, through the studies of dispersion of fast radio bursts, in particular where a fast radio burst is seen through another galaxy, we can say very firmly that these missing baryons are in the space between the galaxies. So this has become a very exciting and a very hot topic with lots of interesting results and probably also some useful results. The missing baryons was a particularly good one, a very significant result. Don't quite know where this is going to go next. We are collecting bursts rapidly. Maybe one a day is pretty good going. Not quite sure what happens next, but it's an area to watch. Fast radio bursts, watch it. Thank you.
Thank you very much for a very interesting talk. And we have some questions from the audience. So, but I would like first to start with my own question. So you mentioned that the only life around the telescope was some kangaroos. So I wanted to ask, what could be the cumulative effect of kangaroos running around on the observations?
I doubt that's a problem, but of course, as they jump, they provide quite a thump. But telescopes are built to resist even smallish earthquakes. They're quite well padded, so to speak. So I think the kangaroos would have to jump in unison to be its effect. And generally speaking, kangaroos don't do much in unison.
Okay, so it's just more for nice fauna around the telescope.
Yep.
Yeah, sounds good. Okay, now I will move to the questions from the audience. And the first question is, do we know how large the sources of these fast radio bursts have to be?
They must be less than a light second, because the pulses are under a second long, some of them. So maybe even shorter than that, but less than a light second, that's for sure.
Okay. Could fast radio bursts be closer but in dense regions so that they become dispersed?
They could if we had only a few of them. And we also really know quite well what the dense regions in our own galaxy are. So we would be suspicious if they were behind those dense regions. But we've now got so many from all over the sky that there must be a lot of dense regions in the sky.
Okay, interesting. Are there any that have been detected closer?
I don't think so. Not as far as I know.
Okay. Here a comment from Apostolos. Thank you, Jocelyn, for a wonderful talk. How do you see the future of fast radio burst detections and research around radio transients go in the next few years?
Certainly radio transients in general, well, even transients in general, is a very important field. And it's a field where there's going to be more equipment opening up. In Chile, there is the massive Vera Ruben telescope, which will come online in a few years. It's particularly designed to study time domain things that rise or fall in strength on quite a short time scale. And depending who you believe, it will either see 1 million or 10 million such things per night. This means the data cannot be analyzed by humans. It's going to have to be done by computers. And of course, it's going to be crucially important what kind of stuff that the computers will accept and what kind of stuff they will reject. And that's going to be quite interesting of itself. But the Vera Ruben telescope will obviously, I think, reveal a lot more of what we already know about, a lot more that we don't know about. And if anybody's moving into research in astronomy, I would recommend going that way, because it's going to be very exciting and huge fun for the next few years.
Okay, well, thank you also for the tip. So everybody who is thinking now about their bachelor, master, PhD projects, possible potential postdocs, consider going into transient astronomy. Another question from our YouTube viewers. What would be the chances of catching a fast radio burst with a big amateur dish? For example, the 9-meter dish of Grotter Weber.
I think probably the dish aperture is only one of the factors. The other is the receiving equipment set up to have very, very short integration time, something like 1/10 of a second. Normally, when you're using a fairly small dish like that, you sit and stare at a source. It's a bit like taking a long exposure with a camera. You have a long exposure, and everything that happens in that exposure is all mushed together and averaged out. So the limitation might not actually be the size of the dish, it might be the receiving equipment.
Okay, interesting. Thank you. Another question, what do you think about the inclusion of minorities and women in science, particularly astronomy, over the last few decades?
It's getting better. but it's still got some way to go. I keep an eye on the data of the International Astronomical Union, which is for professional astronomers. And women are still very much in a minority. I don't know about other minorities. The data is only collected under two headings, male or female, which these days aren't adequate, but that's what it's been historically. But in terms of gender balance, women are still in a minority, although since they've introduced a more junior membership, then the fraction of females is much higher at the younger age groups, which is encouraging.
Yeah, that's true. Another question, because of the pulses, could you live near a pulsar?
Not somewhere where the pulses shone on you, where the beam shone on you. The beam's fairly narrow. You could live well away from where the beam crosses and be okay, but no, not in the beam. And I'd like a very reliable spaceship because the gravity's very strong and I would not like to get pulled in.
Yeah, I think also what is very interesting that, of course, we know that the first exoplanet around the main sequence star was discovered in 95, and it was a hot Jupiter exoplanet. But that actually, technically, the very, very first exoplanet was detected a couple of years before that around the pulsar.
That's right. Yes. Yep.
And I think that it should be very, extremely dangerous, but also interesting world around to have an exoplanet around a pulsar.
Yeah, exactly. Exactly. Yes. And interesting also to wonder, were those planets round the star that became the pulsar? Because it went supernova. And you might think that might dispel planets. Or were they acquired subsequently? We actually know of several, at least a few pulsars that have planets. And we're fairly certain that in most cases, the planets have been picked up later.
So, for example, that they were, let's say, gravitationally attracted from a star passing by?
Yes, pinched, stolen.
Okay, interesting. Because, for example, around the pulsar where the first exoplanet was found, I think now in total that system has 3 exoplanets.
Yes, I think so. Yeah, we know of, I think we know of some others with planets, but that's the most famous one.
Yeah, so it's quite a crime. Instead of stealing 1 planet, while the pulsar stole 3.
Yes, but you know that there are also a number of orphan planets.
Yeah, I think that is also very interesting. Yeah,
it is, isn't it? Yes, and they're finding more and more of those.
yeah. The tricky part that, of course, it's very hard to detect them, because when you have a host star, then you have quite some radiation from the host star that is reflected from the surface, for example, of the planet, or some gravitational perturbances, etc. But if it's just a lonely planet by itself, then it's very, very complicated to discover it.
The lensing effect is quite useful. That's how they found a number of them.
Yeah, that's really cool. Okay, more questions. Question from Vlad. Personally, besides the radio regime, which one is your second favorite and why?
I had great fun working in X-ray astronomy because I was there at a particularly exciting time. Worked with the Ariel 5 satellite, which was a X-ray astronomy satellite shared with the USA. So that was huge fun, a lot happening. I was also involved in the early days with the James Clerk Maxwell telescope, in which the Dutch were partners. So I got to visit Netherlands quite a bit, and I even learned a bit of Dutch, which I have now forgotten.
Okay, nice. Did you like Netherlands?
Yes, very much. Very, very much. It was a very interesting time in my life. And because I was doing user liaison for the telescope, I legitimately traveled in the Netherlands and in Canada, which was the other partner country.
That's beautiful and very interesting international experience.
Mm. And having
Yeah.
to go to Hawaii was really tough.
Yeah, I can imagine. Yeah, it's very far. Yeah, it's tough.
It's tough. Yep.
One more question. Do you think that first pulsar would have been detected if the data reduction would have been done only by computers?
Yeah, that's something that worries me quite a bit. I think probably not, to be honest, because we would not have programmed computers to look for these things. We had no idea such short duration things existed. It was a whole opening up of time domain. And I don't see why we would have programmed the computer to look for such short time resolution. The particular project that I was doing didn't totally require it. At least, sorry, it's a bit complicated to explain. It needed to be recorded at quite high time resolution, but then having got that, you could very quickly average it, and we would probably average it in a computer. So, but at that time, the University of Cambridge had one computer. It took up a whole room. It was made with vacuum tubes, not transistors, and it had memory comparable to your laptop. It was a very early computer.
Yeah, I also read in one of your interviews that computer was not really used for scientific purposes, but more for just managing things for the university.
No, that's not necessarily true. The users were from all parts of the university. And so the radio astronomy group had some time on it, but that was for the aperture synthesis telescopes that really needed computing.
Okay, I see. Well, so the long story short, sometimes it's also good not to have computers.
Sometimes, yep.
We have a question from Jordi Smith. I heard recently that there was a resolution to the missing baryon problem. Is that a well-accepted resolution or just an attempt?
If he's talking about the fast radio burst solution, the fast radio burst people certainly are happy with that, but we'll see. Probably a bit soon to really know what's happening.
Okay. Well, I guess then we will see. And the future will show us what are the possible other explanations for the missing baryon problem. Mm-hmm. I think there are more questions. And so I would like to say that now we switch to our pub quiz. And you can participate in the pub quiz by continuing watching our YouTube stream, or you can also join our Zoom pub. And the link can be seen on the screen. I think, Jake, our viewers, can they see now the link to the Zoom pub?
Yeah, I think everyone should be able to see it. Yes.
Yeah, okay. So the link to the Zoom pub is stem.oo/Zoom pub. And this is now our online pub. So you can stay watching on YouTube or you can go to Zoom. Thank you again very much, Jocelyn, for this, for your time, for the great presentation, for answering so many questions. And yeah, would you like to join our Zoom pub and also participate in the quiz? And yeah, after the quiz to chat a little bit with our viewers.
I think I will disappear at this point. Thank you very much, Katarina.
Okay, thank you very much.
Enjoy the pub.
Yeah, thank you. And thank you. Also, our viewers were writing that you should come to the Netherlands to visit. Again, oh no. Okay, well, I didn't manage to read the comment, but yeah. that Jocelyn should come visit.
She will come when COVID allows, yes. I'm sure.
Yes. Yeah, I agree with Pavel that Netherlands is it's almost as nice as Hawaii. It's also very beautiful. So yeah. Okay, now I would like to give stage to Jake, our pub host, and also our pub quiz host. Jake?
Yeah, I'm going to share this Kahoot code now. You can either come join us in the pub, or you can stay here watching on however you're watching what we're doing. On your device, it will also show the questions as they're coming. So if you've got the delay, sorry about that. So you just have to imagine that whatever I say was a few seconds ahead, but you can still see the questions and answers on the screen as soon as they're there. So hopefully you can now see the Kahoot code. Interestingly not. Let's
Yeah, I think that the sharing doesn't work yet.
Yeah, my computer's just crashed really, so just give it a moment to appear.
Okay.
If you want to join, the code is 589-0864.
589
0864.
0864. So I will read the code again while we're rebooting the computer. 589-0864. And you can log in through the Kahoot app on your mobile device, or you can also go to the webpage kahoot.it and provide the code in there. And please join our pub quiz because it's going to be fun and tricky. And it will be very, oh, I see. Okay, now the streaming works. Great. Okay, Jake, now the floor is all yours. Yes, perfect.
Interesting. See people from the first year class trying to join with their striving for the bottom in Kahoots. Always an interesting technique. In a stroke of amazingness, in today's Kahoot in Introduction to Astronomy, the person called first got first place. We'll give people like 3 more minutes to join, so please make sure that you've got a drink, you've got the app loaded, you're ready for action. Into number 1. There's a lot of Friesland blood in tech crew, I think. Used to be. Think of your name and get joining. Not long now. 1.5 minutes left before we start the epic December quiz. One more minute. Don't see anyone else joining. So it may be less than a minute. Oh, that's a little mean name, but okay. "30 more seconds when we start. Join now. You can see the pin on the screen. You'll also see the questions and answers in real time on your device. However you're watching it, there might be a bit of delay, so pay attention there too. I'll try to make sure there's space between questions also. Here we are ready to go with the epic December. Oh, people still joining. 10 more seconds. Any last joiners? Join now. All right, and here we go with the December quiz. So first question, type your answer. What year was the Lorimer burst discovered? Tricky one to start with. Remember, you need to answer as fast as you can, as correctly as you can, to be able to get the points. If you're answering now, you may as well guess. Points are still descending. Using Google to find it out, it's gonna take too long. No points for Googlers. Still always waiting for that last person to type it in. There you go. A whole vast array of years. Did anyone get it right? 5 people paid attention. Yes, 2007. Well done. Or a lot of Googling to see how many points you got. Yeah, those are pretty slow answers. So well done for knowing how to use Google, guys. We cannot detect fast radio bursts coming from outside our galaxy. Is it true or false? I mean, if you're Googling this one, you're definitely not going to get enough points, because at least 50% of people who just answered randomly will be doing better than you. Now my phone's playing us music, but I can't see where it is. Where? All right, it is false. We cannot detect fast. We can detect fast radio bursts coming outside our galaxy. As Jocelyn said, some of the first ones have been discovered. All right, last place is mine is doing particularly well, so maybe you're not getting the place that you wanted. How will the DART mission deflect asteroids, impacting the asteroid with a spacecraft, impacting the asteroid with a missile, impacting the asteroid with a CubeSat, or impacting the asteroid with an asteroid? We'll tell you there's a lot of debate went on with tech crew about what the definition of different spacecraft, missiles, and other objects are. So go for the least irritating answer, probably. Yeah, they're impacting it with the spacecraft. Last place is fine, still doing strong. Everything's still to play for, so any more questions? Last weekend, the solar orbiter performed a gravity assist maneuver around Earth. Why was this so dangerous? Because of potential collision with Earth, collision with the Moon, collision with the International Space Station, ISS, or due to a potential collision with space debris? Why was this so risky last weekend? Don't know how Googleable that is, so just click a button. Timed out, I guess someone gave up or can't Google fast enough. The last weekend, the solar orbiter performed a gravity assist. It was very risky because of the collision with space debris. We have a lot of space debris around Earth, old satellites, old blown up satellites, all of that kind of thing is there. Stephen walking, climbing onto the leaderboard, but last place is mine, still running strong in first place. The prevailing idea is that all galaxies can only exist if they're held together by the astronomer's will, by dark energy, dark matter, or the dark side. Which was the view about how galaxies need to be held together? Which of these components is necessary? I'm going to skip in like 10 seconds if person number 22 keeps not answering. Also, we here forever. 2, 1, skipped it. All right, yeah, indeed, the prevailing idea is that all galaxies only exist if they're held together by dark matter, but did you manage to answer that fast enough? Apparently last place is mine did. Steve, and walking has dropped off the list, but been replaced by other people. An ultra short period planet completes an orbit in less than, which one of these is the lowest less than? Tech crew. It's all of them are less than all others, but which one is the one to choose? I'm going to skip again in 5 seconds. Indeed. Ultra short period planet completes an orbit in less than 24 hours, which is accurately pointed out behind me to also be less than 12 days, 24 days, and 1 year. But you know what we mean. Oh, Stephen walking back up there, Ninka Kevin. Rising there, last place is mine, going strong. Tech crew having hilarious time. In which wavelength range will JWST operate? Ultraviolet, visible, infrared, or radio? Its primary wavelength range of operations. And skipping in 4, 3, 2, 22 answered. Well done. Infrared is right. Good majority. Who was fastest? Oh, still this little movement around there, edging up on the leaderboard. Everything still to play for. Which of these was not a former year, was not a year when JWST was going to launch? 2021, this year, 2014, 7 years ago, 2007, 14 years ago, or the year 2000? Which of these was not a year when we were going to launch the JWST? Come on, person 22, you can do it. Yes, there you go. And indeed, 2000, not going to be launched. Never planned to launch in that year. All of the others were potential launch dates for JWST, which has taken a long time and hopefully is going to launch this month as of before we started here. Oh, last place is mine. It's sunk down to second place. Will they stay there or will they move up? Which of these missions orbited the moon on December the 24th in some particular year, which is not named? Not this year, obviously, we haven't had it yet, but at some point in history, one of these was famously in orbit around the moon on December the 24th. That everybody should know from their spaceflight history. But where has Kahoot gone? Kahoot has returned. Indeed, Apollo 8 famously orbited the moon on December the 24th, the first Apollo mission to go all the way to the moon and around it. Little bit of movement around there. Keep going. Remember, be fast, be right. Santa's home at the North Pole, which we also discussed, has spectacular auroras. What causes these aurorae? Rudolph, charged particles from the sun, the meteor showers, or the spirit of giving? Disclaimer, I don't write the questions, I read them out. Indeed, charged particles from the sun. If you chose Rudolph the red-nosed reindeer, fine. Oh, Rally getting up there. Good streak. 10 correct in a row. Nice job. All the rest going well. Still everything to play for. What kind of symmetry do all snowflakes have? 4, 6, 8, or it depends. They do have 6-fold symmetry. If you're lucky enough to live in the USA, you can go online and buy hexagonal water. I've seen recently, which is great. Just freeze some water and you get that hexagons. Rally's still up there. Come on, last place is mine. So now we come to a round of what's in a name. So all of the planetary bodies in the solar system have a theme for naming of all of their features, all of their moons, and all of that kind of thing. For example, the moons of Uranus are all named after Shakespearean characters. So in each of these categories, what's going on? What is the naming theme for Venusian features? Features on Venus, love languages, precious metals, gems, or goddesses? Come on, 22, you can click it. You can click it. 4 more seconds to click it, else I'm skipping. I'm skipping. They are named after different goddesses. Of course, Venus itself named after a goddess, and then all of the features named after others. Oh, last place is mine. Back in first place again. True or false? The names of features on the dwarf planet series, one of the in the asteroid belt, are all related to breakfast. True or false? Yeah, it's a real thinker. Could it be true? Could it be false? Who knows? Oh, I'll give you 5 more seconds before I press that skip. Oh, you got there. False, they're not related to breakfast, at least not directly related to breakfast. If you want to send us a list of names of features on the series and how you can relate them to breakfast, then we will give you a prize of a pack of breakfast cereal, I'm sure. Last place is mine, still up there. Everything can still change. No one's in secure spots yet. The asteroid Bennu, visited by the OSIRIS-REx mission, had the naming theme of dog breeds, Egyptian rulers, mythical birds, or Tolkien characters. A lot of thought going into that for some. Here's 3 more seconds. Always threat works. It is named after mythical birds, not very popular. You would think Egyptian rulers, as Osiris was not an Egyptian ruler, though it was an Egyptian god with the figure of a mythical bird. So all the rest are also named after mythical birds. Last place is 9 is there. P, I have a good answer streak of 8. The Jovian moon Europa has features named after Celtic myths. True or false? Keep thinking for like 3 more seconds, then we're skipping. 2, 1. Amazing. The Jovian moon Europa has features named after Celtic myths is true, in fact. And give us some feedback. How was your evening this evening? Type in an answer. Short answer. Tech crew is very surprised about the speed of some of the answers. We'll see. Some boxes looking bigger than others because more people typed it, or just because they typed really long words. Oh, now we go. At least 2 people voted for one thing. Let's see what you said. Awesome. Busy and stressful. Love Jocelyn. Delightful. Amazing. Pretty all right. Great and good. Yeah, we'll take them. A vibe. Good for you. All right, let's check out the quiz podium. If you won, please take a screenshot on your device and then you can send it to any of us organizers and you will get that voucher to use at Bookshop Cafe, or if you're not in Groningen, we'll figure out something else. And last place is mine. Congratulations on being the winner and not securing your last place at all in any way. So yet again, thanks for playing. If that's you, remember to capture that on your device and let us know. Now we can see how badly you all did and everything, but we won't look at that. All right, guys, so thank you for joining us this evening. And if you want to carry on discussing the talk, meeting with the organizers and that stuff, please do join the Zoom pub. And the link is behind me right now. And then we'll leave that up there for about another minute. And then we'll be in the pub having our discussion in there. So please join that and we'll see you there in 1 minute.